Welcome to the brief presentation on input information required from you to test the compliance with the applicable standards. Please mention about the correct name of the company, which shall be reflected on the test report. Please mention correct address of the applicant, name of the contact person, and his number. Please ensure that the person must be enough technical to answer the technical questions of the inspector. You are requested to write the quotation number as well, so that we can correlate it with our records. Please write the tests which you would like us to conduct on your equipment. On the test report, we can write the trademark, model or type references, technical name of the machine. Please write the correct information, as it will be on the front page of the test report. Sometimes, applicant can be different than the manufacturer. In that case, please write the name of the manufacturer, serial number of the equipment to the testing, approximate dimensions of the machine, and approximate weight of the machine. Please give us the intended use of the machine and some description about the equipment under testing. This information will be a part of the test report. In the machine, if all accessible conductive parts connected to protective earth conductor of mains, then it is class I. In the machine, if double insulation, 2 layers between live and accessible part, or 1 reinforced insulation, then it is class II. In the machine, when voltages are not exceed 25 VAC or 60 VDC, it is called as safe extra low voltage, SELV. Then it is class III. Pollution degree 1. Equipment use in clean room environments, inside of sealed components. Pollution degree 2. Equipment use in equipment being evaluated to 60,350 laboratories, test stations, office environment. Pollution degree 3. Equipment use in electrical equipment in industrial and farming areas, unheated rooms, boiler rooms. Pollution degree 4. Electrical equipments for outdoor use. Type B applied part. Generally non-conductive, and can be immediately released from patient. Type BF. Conductive or medium. Long-term contact with other than heart. Type CF. Conductive or medium. Long-term contact with heart. Mention the names of all applied parts, optional as well, along with their use. Please specify the total allowable range in the Form 207 to 253 VAC. Also specify a set rated current. Specify the rated frequency. Specify the rated power. Specify the type of material used for the enclosure, for e.g. metallic, plastic, etc. Comparative tracking index. If the material group is not known, material group IB shall be assumed. Specify the exact fuse rating as per user manual or bill of material. Please submit us the details of the battery, Please submit us the details of the category AP and APG category app is related to rating for ME equipment or an ME equipment part complying with specified requirements on construction, marking, and documentation. In order to avoid sources of ignition in a flammable anesthetic mixture with air. Category APG is related to rating for ME equipment or an ME equipment part complying with specified requirements on construction, marking, and documentation. In order to avoid sources of ignition in a flammable anesthetic mixture with oxygen or nitrous oxide. Oxygen-rich environment means the environment whereof the oxygen percentage is more than normal. Term referring to equipment that, once installed and placed into service, is intended to be supported by the hand, one or more socket outlets, intended to be connected to, or integral with, flexible cables, cords or ME equipment for providing supply mains or equivalent voltage. The colors of indicator lights and their meanings shall comply as follows. Red warning. Immediate response by the operator is required. Yellow caution. Prompt response by the operator is required. Green. Ready for use. Dot matrix and other alphanumeric displays are not considered to be indicator lights. Through any opening provided for the adjustment of preset controls that can be adjusted by the responsible organization in normal use by using a tool. Conductive parts of capacitive circuits that become accessible after ME equipment has been de-energized. Means for reducing the risk due to electric shock in accordance with the requirements. Basic insulation. Insulation providing basic protection against electric shock. Double insulation. Insulation comprising both basic insulation and supplementary insulation. Reinforced insulation. Single insulation system that provides two means of protection. Supplementary insulation. Independent insulation applied in addition to basic insulation in order to provide protection against electric shock in the event of a failure of basic insulation. Conductor other than a protective earth conductor or a neutral conductor, providing a direct connection between electrical equipment and the potential equalization busbar of the electrical installation. Where means are provided for varying the temperature setting of thermostats in ME equipment. The temperature setting shall be clearly indicated. Device that, during an abnormal condition, limits the temperature of electrical equipment or of part of it, by automatically opening the circuit or by reducing the current. And that is so constructed that its setting cannot be altered except by qualified service personnel. Time period specified by the manufacturer during which the ME equipment or ME system is expected to remain safe for use. ME equipment, ME system, and their parts or accessories intended to come into direct or indirect contact with biological tissues, cells or body fluids shall be assessed and documented according to the guidance and principles given in the ISO 10993 series of ST standards. ME equipment, its parts and components that heat a flammable anesthetic mixture with oxygen or nitrous oxide shall be provided with a non-self resetting thermal cutout, as an additional protection against overheating. If equipment of software or PEMS, please provide us the software risk management plan, life cycle, risk management process, requirement specification, software architecture and design, implementation, modification, verification and validation. Please give the information of transformer as requested. Please view the information of switching mode power supply as requested. Please give the critical component list. Please ensure that the critical components are high integrity components, and those which are flow down from your risk management file. Please give us a list of accessories and detachable parts. In this section, you have to identify applicable limits for your equipment under testing. Please note that CISP 11 can be used for industrial, scientific, and medical equipment. If the equipment under testing fall under the category of household appliances, CISP 14 limits can be used, and for electrical lighting and similar equipment, CISP 15 limits can be used. The limits are based on the classification of use, like Class A and Class B. Class A equipment is an equipment suitable for use in all establishments other than domestic, and those directly connected to a low-voltage power supply network, which supplies buildings used for domestic purposes. Class B equipment is equipment suitable for use in domestic establishments and in establishments directly connected to a low-voltage power supply network, which supplies buildings used for domestic purposes. About Group I and Group II. Group 1 contains all ISM equipment, in which there is intentionally generated and used conductively coupled radio frequency energy, which is necessary for the internal functioning of the equipment itself. Group 2 ISM equipment means Group 2 contains all ISM equipment in which radio frequency energy is intentionally generated and used in the form of electromagnetic radiation for the treatment of material and EDM and arc welding equipment. Class 0 means well-protected electrical environment, often within a special room. All incoming cables are provided with overvoltage, primary and secondary protection. The units of the electronic equipment are interconnected by a well-designed earthing system, which is not essentially influenced by the power installation or lightning. The electronic equipment has a dedicated power supply. Surge voltage may not exceed 25 V. Class 1 partly protected electrical environment. All incoming cables to the room are provided with overvoltage, primary protection. The units of the equipment are well interconnected by an earth line network, which is not essentially influenced by the power installation or lightning. The electronic equipment has its power supply completely separated from the other equipment. Switching operations can generate interference voltages within the room. Surge voltage may not exceed 500 V. Class 2. Electrical environment, where the cables are well separated, even at shorter runs. The installation is earthed via a separate earth line to the earthing system of the power installation, which can be essentially subjected to interference voltages generated by the installation itself, or by lighting the power supply. 2. The electronic equipment is separated from other circuits, mostly by a special transformer. 4. The power supply. Non-protected circuits are in the installation, but well separated, and in restricted numbers. Surge voltages may not exceed 1 kV. Class 3. Electrical environment, where power and signal cables run in parallel. The installation is earthed to the common earthing system of the power installation, which can be essentially subjected to interference voltages generated by the installation itself, or by lighting current due to earth faults, switching operations, and lighting in the power installation may generate interference voltages with relatively high amplitudes in the earthing system. Protected electronic equipment and less sensitive electric equipment are connected to the same power supply network. The interconnection cables can be partly outdoor cable, but close to the earthing network. Unsuppressed inductive loads are in the installation, and usually there is no separation of the different field cables. Surge may not exceed 2 kV. Class 4. Electrical environment, where the interconnections are running as outdoor cables along with power cables, and cables are used for both electronic and electric circuits. The installation is connected to the earthing system of the power installation, which can be subjected to interference voltages generated by the installation itself or by lighting currents in the carrange due to each fault, switching operations, and lightning in the power supply installation may generate interference voltages with relatively high amplitudes in the earthing system. The power supply network can be the same for both the electronic and the electric equipment. The interconnection cables are running as outdoor cables even to the high voltage equipment. A special case of the environment is when the electronic equipment is connected to the telecommunication network within a densely populated area. There is no systematically constructed earthing network outside the electronic equipment, and the earthing system consists of pipes, cables, etc. only. Surge voltage may not exceed 4 kV. Class 5. Electrical environment for electronic equipment connected to telecommunication cables and overhead power lines in a non-densely populated area. All these cables and lines are provided with overvoltage primary protection. Outside the electronic equipment, there is no widespread earthing system, exposed plant. The interference voltages due to earth faults, currents up to 10 kA, and lightning, currents up to 100 kA, can be extremely high. The requirements of this class are covered by the test level 4. Class X. Special conditions specified in the product specifications. Level 1. Well-protected environment. The installation is characterized by the following attributes. Suppression of all EFTB in the switched power supply and control circuits. Separation between power supply lines, AC and DC, and control and measurement circuits coming from other environments belonging to higher severity levels. Shielded power supply cables with the screen's ear at both ends on the reference ground of the installation, and power supply protection by filtering. The computer room may be representative of this environment. The applicability of this level to testing of equipment is limited to the power supply circuits for type tests, and to the earthing circuits and equipment cabinets for post-installation tests. Level 2. Protected environment. The installation is characterized by the following attributes. Partial suppression of EFTB in the power supply and control circuits which are switched only by relays, no contactors. Separation of all the circuits from other circuits associated with environments of higher severity levels. Physical separation of unshielded power supply and control cables from signal and communication cables. The control room or terminal room of industrial and electrical plants may be representative of this environment. Level 3. Typical industrial environment. The installation is characterized by the following attributes. No suppression of EFTB in the power supply and control circuits which are switched only by relays, no contactors. Poor separation of the industrial circuits from other circuits associated with environments of higher 70 levels. Dedicated cables for power supply, control, signal, and communication lines. Poor separation between power supply, control, signal, and communication cables. Availability of earthing system represented by conductive pipes, ground conductors in the cable trays, connected to the protective earth system, and by a ground mesh. The area of industrial process equipment. The power plants. And the relay room of open air H.V. Substations may be representative of this environment. Level 4. Severe industrial environment. The installation is characterized by the following attributes. No suppression of EFTB in the power supply and control and power circuits which are switched by relays and contactors. No separation of the industrial circuits from other circuits associated with environments of higher severity levels. No separation between power supply, control, signal, and communication cables. Use of multicore cables and common for control and signal lines. The outdoor area of industrial process equipment, where no specific installation practice has been adopted, of power stations, open air H.V. substation switch yards, and gas-insulated switchgear of up to 500 kV operating voltage, with typical installation practice, may be representative of this environment. Level 5. Special situations to be analyzed. The minor or major electromagnetic separation of disturbance sources from equipment circuits, cables, lines etc. And the quality of the installations may require the use of a higher or lower environmental level than those described above. It should be noted that equipment lines of a higher environmental level can penetrate a lower severity environment. Please contact us as soon as possible for any kind of explanation. In understanding the basic information input points,